Good morning, math students. This week's lesson is on circles, specifically the diameter, radius, and circumference of circles. Now, I'm hoping that before you came to this math tutorial, you took the time to watch the read-through of circumference and the dragon of pi. Okay. Now, the reason I want you to do this is because it takes the time to explain how these different parts of a circle relate to each other. So if you haven't taken the time to watch the read through of this, pause the video now, go over to the links that I posted and watch the read through first, okay? Because it is in fact very helpful. So some terms here that we have to be aware of with regards to circles. There are special names for the parts of a circle, okay? So the distance all the way across a circle at the widest point is called the diameter, okay? The distance from the middle of a circle to the edge is called the radius. And it's actually the radius that we use when we choose to draw a circle. Whenever you get out a compass, you are in fact creating a radius between that stabby part of your compass and the pencil end of your compass. That's the radius. And you have to keep the radius the same all the way around, right? If your compass closes on you, you don't get a circle out of it. What you end up with is a weird spirally sort of shape. The characteristic that makes a circle is that it doesn't matter where you draw the line. If you draw a line from the middle of a circle to its outer edge, the measurement will always be identical, okay? That'll always be the same. So the radius of a circle doesn't matter if you measure it here or here or here. It's always exactly the same. Okay, term number 3 you have to know is the circumference of a circle. This means that if you were to measure the distance all the way around the outer edge of a circle, you would have the circumference. Okay, and if you read the book, you would have noticed that radius, yes, they named this kid after part of a circle, don't ask, that radius had to measure the outside edge of a number of circles, and he divided the outside edge by the distance across the circle, okay? So he did this. He took the circumference, he divided it by the diameter, and every single time he came up with the same number. And we actually have, we've dedicated a Greek letter to this number. It has a special name. This number is called pi, and the symbol for it looks like that, okay? It looks kind of like a table, sort of, but it is a Greek letter. It's called pi, and the approximate value of pi, and this is approximate, is 3.14. Now, pi is a weirdo, okay? So we say pi is approximately 3.14, but it's not exactly 3.14. And what's interesting is we've talked a bit about repeating decimals. Pi is not a repeating decimal. They have calculated the value of pi to millions, billions of place values. And the simple fact of the matter is that there is no pattern. The numbers never repeat. They keep calculating and calculating and calculating. Now, the fun thing is, if you guys want to, when you're at home, you can do this for yourself. You could take household objects, like say some canned goods you might have in your home, take a piece of string, go all the way around the outside of the canned object, find that distance. If you were to measure this distance, that would be your circumference. And then you would measure across the widest point, that would be your diameter. And if you take that distance around and divide it by the diameter, you should get close to 3.14. Now, it's not the easiest thing in the world to do because measuring with string is a little bit awkward, but you should definitely get a number close to 3. If you find you have some spare time on your hands this week and you want to prove mathematics right or wrong, take some time, do some measuring. Household objects like cans or CDs you might have kicking around, anything round will do. If it has a circle, it has both a circumference and a diameter. And that means you can do the math that's necessary to calculate pi for yourself, which is pretty cool. It means we can never be without this value. It's actually impossible to forget, so long as you remember how we got it in the first place, okay? So with that said, because we know that every time you take the circumference of a circle and you divide it by the diameter, you always, always, always get pi. This means that we can calculate some other values as well, okay? And so in order to show you why this works, I'm actually going to lean on a piece of math that we call fact families. Some of you guys may remember these. So fact families are things like 2 times 3 is 6. Okay? 2 times 3 is 6. Because 2 times 3 is 6, we know that 3 times 2 is also 6. That part's easy. But we also know that 6 divided by 3 is 2. And we know that 6 divided by 2 is 3. These are all related to each other. Okay. Now the cool thing about this circumference divided by diameter equals pi is that this is also a fact family, although the numbers in it are a little bit more complicated. Okay. So we can rearrange this the same way. Just like circumference divided by diameter gives us pi, if we take circumference and divide by pi, we get diameter. Because we know that if you take this, divide by that, you get this. And if you take this, divide by that, you get this. That means if you multiply these two together, you get that. So we can do that as well. If you take pi and you times it by diameter, you get circumference. Okay? Voila! We have the formula that we're going to be using in this unit, because there are times you may want to know what the distance is around the outside of a circle, even though you can't measure it. So we're going to be using this formula to calculate the circumference of a circle. You can also use this to calculate the diameter or radius of a circle if you have the circumference to start with. There's also a really simple formula that it's so basic that it's almost not worth mentioning, but we will mention it. If you know the diameter of a circle, that's the distance all the way across. And you want to know the radius of a circle, that's the distance halfway across. Well, diameter is equal to radius times 2, right? It's twice as big as the radius. So we've got some formulas there as well, okay? So there's not a whole lot of this work I'm asking of you. We're mostly going to work with the circumference formula because this is pretty basic. Sometimes, though, you're going to have to rely on this if you're given the radius and you're looking for the circumference. So we're going to start with this problem here. We've got a diameter, and I'm going to suppose that this diameter is, let's say 2, okay? This diameter here is 2 centimeters, okay? So we've got a diameter of 2 centimeters. I want to know the circumference. Well, I've got a trusty formula for that. Circumference is equal to the diameter times pi. Pi times the diameter. Pi always goes in front. Don't ask why. It just does. It's because it's a constant value, okay? So circumference is pi times the diameter. That is our formula step. Don't forget to write down the formula. Now we move on to the substitution step. So circumference is 3.14 times, in this case, 2. Now you should be able to do a quick estimate for circumference. It's actually easy. Pi is about 3. 3 times 2 is 6. This should be close to 6, right? But we can also do the long work of multiplying this. 3.14 times 2, 1 digit at a time. We got 8, 2, 6. Place that decimal. It is 6.28 centimeters. And this is not squared, okay? Bear this in mind. This is not centimeters squared. It is not area. It is a measurement of a line. Remember, when we measured circumference, we used a string to measure around the outside edge. It is not a flat surface that we're measuring. It is a line. It's a linear measurement. So that's why this is still centimeters. It's not centimeters squared, okay? Make sure you've got that straight. Area of triangles, area of parallelograms. If you're calculating that area, you need to have that little squared symbol, but this is a line we're talking about, okay? Now we're going to make things a little bit harder, okay? So if I give someone a radius, let's say that this particular radius was, I don't know, let's suppose that it was 3 centimeters. Okay. Now I know that the formula for area of a circle is circumference. Circumference is, sorry, I said that completely wrong. The formula for circumference of a circle is pi times the diameter. So I'm going to write that down. But I don't have the diameter this time. I have the radius. How do I find the diameter from the radius? Well, diameter is twice as big as radius, right? So that means instead of diameter, we are going to take the radius and times it by 2. Okay, we're going to times the radius by 2. And so actually, this is on your formula sheet in a simplified format. The simplest way of writing this is to say that circumference is 2 times pi times the radius. Again, the 2 goes in front because it's a coefficient. We'll talk about that in algebra, all right? So this is how it looks nice and tidy. That's how you tidy up that work. If you hate having to remember a second formula, that's okay. Do a little calculation on the side, times the radius by 2 to get the diameter, and then use the diameter formula. You can do that. But the formula sheet does have radius on it. You don't have to remember it perfectly, although it's a good idea to memorize it. So you can look up this formula if you want to, okay? So circumference is 2 times pi times the radius. So that's 2 times 3.14 times, what was our radius again? 3 centimeters. Okay, so here we go. We already know, because I just did it over here, that 2 times 3.14 is 6.28. And believe me, by the time this unit is done, you will have memorized that, okay? 2 times 3.14 is 6.28. It is so constant that there's times when I, as a teacher, don't bother to write down this part. I just know it's 6.28 and I move on, okay? So 6.28 times 3, now we have to do the math. 8 times 3 is 24, carry the 2, 3 times 2 is 6, plus 2 is 8, 3 times 6 is 18, and we have 2 decimal places. So our circumference is 18.84 centimeters. Again, not squared. This is just a linear measurement. Now, there's one more thing I am going to ask you to do in this week, and that is to calculate the diameter of a circle given the circumference. But we're not going to do that in this tutorial video. Go ahead, get started on your math sheets. At the very bottom, okay, and I think it's not until the second one, you will find that you're asked to calculate diameter based on circumference, okay? When you get to that point, watch the second tutorial video where I will explain how to do that. Have a good day.